You know, when you look at a map, there's that tiny little strip of land where two massive oceans almost touch, the Isthmus of Panama. For centuries, that little sliver was like an impenetrable wall, forcing ships on this unbelievably long and dangerous journey all the way around South America. So, what was the solution? Well, to build a water bridge right through a continent. Okay, let's get into how this thing actually works.
But here's the real head-scratcher. Panama isn't flat. Not at all. It's got this spine of hills and rock running right down the middle. So the question that stumped some of the best engineers in the world for decades was this. How on earth do you get a gigantic ship, basically a floating skyscraper, to climb over a mountain range?
So the total height a ship has to climb is about 26 meters. Now that might not sound like a huge number, but picture this. That's about the same height as an 8-story building. Now imagine trying to lift a vessel that weighs tens of thousands of tons that high up, and then gently setting it back down on the other side. The winning idea, the one that finally cracked the code, was to stop fighting the terrain and start using it. The solution wasn't to keep digging down, but to go up, using a series of locks that basically act like a giant water elevator.
Now, the secret ingredient that powers this whole colossal machine is what's truly amazing. It's not electricity, it's not steam, it's just gravity. Seriously, the entire lock system operates without a single pump. I mean, think about that for a second. No complex machinery to break down, no massive energy bills, just the reliable, constant pull of the earth. It's a design that's both incredibly powerful and beautifully simple.
So how does this water elevator actually work? Let's walk through it. Okay, so first, a ship sails into a sealed chamber. Just think of it like a giant concrete bathtub. Then, these massive steel gates swing shut behind it, sealing it in. Then, some valves open up and water from the higher level just flows right into the chamber, all powered by gravity. And as the chamber fills up, the ship inside just rises with the water. Once it's at the same level as the next section, the gates in front open, and it sails on through to do the whole thing over again. It's a literal staircase made of water, and the ships climb it one step at a time.
Right, but an elevator like this needs an incredible amount of water to work. We're talking millions and millions of gallons for every single ship. And all that water had to come from somewhere reliable. The problem was, the main river in the area, the Chagres, was anything but reliable. It was wild, unpredictable, and known for these absolutely devastating floods. And this is where the genius of the plan really kicks in. The engineers turned that problem, that wild river, into the solution. They built a gigantic dam across the Chagres River, and in doing so, they created the massive artificial Lake Gatun. This lake is a triple threat. It stores all the fresh water needed for the locks, it tames the river's floods, and maybe best of all, it became a huge navigable waterway for the middle part of the canal itself.
So here's the crucial trade-off. The locks work by consuming water. Every single time a ship goes through the system, a massive volume of fresh water from Lake Gatun is used to lift it up and then lower it down. And all that water, it gets flushed out into the ocean. It's gone. That's the operational cost for every single ship that makes the journey.
Now that we've seen how this incredible lock and lake system works, it kind of makes you wonder why it was even necessary. Well, that's because before this brilliant idea, there was another plan, a huge, ambitious, and ultimately disastrous attempt to build a totally different kind of canal. See, the French were coming off their huge success building the Suez Canal, which is a sea-level canal, and they tried to just copy and paste that plan in Panama. They wanted to dig one single massive trench straight through the continent. It was a brute force approach, a plan to fight and conquer the terrain. The American plan, the one that worked, was the exact opposite. It was all about using the terrain, building up with locks and lakes. This cut down the amount of digging they had to do and turned an impossible fight into a manageable engineering puzzle.
And that brute force plan? Oh, it was doomed from the start. The geology was all wrong. They had impassable mountains and rock that just shattered their equipment. The constant tropical rains caused massive landslides. The soft jungle soil would just collapse into their dig sites, burying machinery and men. That wild Chagres River we talked about, it kept flooding their work sites. And worst of all, there were the invisible enemies, yellow fever and malaria. These diseases just tore through the workforce, killing over 20,000 people and collapsing the whole project in a financial and human catastrophe.
So the canal that finally opened in 1914 was an absolute triumph. But it was never something you could just build and forget about. To stay relevant in a changing world, it's had to keep evolving. And today, it exists in this really delicate balance.
For most of the 20th century, the canal's physical size literally set a global standard. If you wanted your ship to use this critical shortcut, it had to fit. And so the term Panamax was born, defining the maximum size a ship could be. I mean, think about that. Shipbuilders all over the world were designing their fleets based on the width and length of these concrete chambers in Panama.
So after opening in 1914, the canal was managed by the U.S. for most of the century. Then, in 1999, control was officially handed over to Panama. And by 2016, with global trade demanding bigger and bigger ships, a massive expansion project was completed. They opened new, larger locks to handle a whole new class of giant Neo-Panamax ships, making sure the canal wouldn't become a relic of the past.
And yet, despite all the upgrades, all the modernization, the canal's fundamental vulnerability has never changed. Its true fuel isn't the oil or coal that powers the ships, it's the fresh rainwater that pills like Gatun. Without enough rain, the system simply cannot work at full capacity. It's that simple.
And this brings us to the final and most crucial takeaway. The Panama Canal isn't just a masterpiece of engineering. It's also a kind of thermometer for our planet. Its entire operation is directly tied to weather patterns and climate cycles. And as those patterns become less predictable, so does the future of this vital artery for global trade. The rules of a game that has relied on gravity and rainwater for over a century, well, those rules are changing, and it leaves you wondering, how will this incredible marvel adapt to the challenges of the next 100 years?